All right, so letter A, x minus a. As a is increasing, what is happening to x and y?
And what? Oh, why?
Y, W-H-Y, not y the variable. Yes, I'm adding in my own variable now.
It's increasing.
It's increasing, it's going to stay the same.
You got it.
Letter A.
Wait,
As a is increasing, what is going to happen to x?
increase.
Increase? How many say increase? That's what they're saying.
Yeah.
That's not what you were saying, though, was it? Okay. So we are saying as a increases, x is increasing also. Why? There's that question. Why? That's right. X increases also because what do I want to say? I know what I want to say. How should I say it? Do you know what I want to say?
Yeah.
I know you don't want to go there, right? Because a and x have to be the same value, correct?
Yeah.
Because a and x are the same value or number. Because if one number minus another is 0, then they have to be the same. Correct?
Yeah.
All right. You're like, oh, man. Now, see, doesn't that seem so easy now? No? You don't get it? So, let's say A was 1 initially. Initially. What would X have to be? 1. Because 1 minus 1 is 0. So we want A to increase. So let's make A 5 now. If this is still 0, what has to happen to our X value? It has to increase also, and it has to increase to be the same as our A value because we want our answer to be 0. Does that help a little? You can look back at this video later, many times you want. And we can work on it later also. All right, letter B. Letter B is another good one. These are all great problems. So A times X is equal to 1. 1 is not going to change. The answer is always going to be 1. Or the solution, not the solution. The product will always be 1. So as A increases, tell me what's going to happen to X. What? I got an I don't know. Increases. Anybody else? What do you think? I think people are not thinking. Come on, people. This is not terribly difficult, but you do have to think. As A is increasing, what has to happen to X? Huh? You're not clueless. It's just Friday. 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 Yay, it's Friday.
I don't know. This the only one.
Leia, please put that away. Talk to me. Come on. Does anybody have an answer? What do you think? What? Why? Doesn't have to be a decimal. A fraction. Okay. So what do we call A and X in this type of situation? What do we call those? No. So as A increases, X is going to decrease. I should have picked a different color. X is going to decrease because, what do we call A and X when you set them equal to 1? 1 would be the product. They would be factors, but specifically they are reciprocals, right? Because A and X are reciprocals. So if I had A was 3, what would X be?
You said what?
If A is 3, what would X be in order to get positive 1? 1 over 3, right? 1/3. The reciprocals. So as A increases, if I make A equal to 8, what's A or X going to be? 1 over 8. So it is always going to get smaller, right? Right? Yes? Yeah, it decreases. Were you going to say something or?
No, because you just threw out reciprocal. Like I heard that word a long time, so I thought it's when you flip that.
It is.
It is when you flip that.
Yeah, so 3 over 1 times 1 over 3. But usually, well, sometimes you don't put the 1 under the whole number out front. One more time.
No, what you just said the last part.
I said, so usually if you have a whole number like 5, usually you just write it as 5. But you can also write it as 5 over 1, and its reciprocal would be 1 over 5. If I have, I don't know, 7, make it over 1 times 1 over 7. So as A gets larger, your X value has to get smaller because you multiply them together to equal 1. Okay. Any questions on B? All right, let's go to the next one. I actually saw some people have an answer for C. So A times X is equal to A. So as A is increasing, what happens to X? Your solution stays the same. Okay, so as A, it always helps if you have something. So as A increases, X is going to stay the same. Why?
Because if you move the A up and you keep the X at 1, anything you move that A to, anything you change that A into, it will give you A.
Yeah. If you have any value set for A and it equals A, what does X have to be? 1. So X must be 1. It must be 1. So if A increases, doesn't matter. 100 times something gives you 100. 1,000 times something gives you 1,000. That means X has to be 1. Okay? Questions on that?
That was for C, right?
That was for C, yes. Got one more.
So,
Yes, question? Question on C still? Yes? Just say yes, it's quicker.
I don't know.
You're on C though, right?
Yeah.
Okay.
Not all of them, but I think I get it, but I think I don't. I don't know. Then you can move on. It's okay.
I will post the video. It will go on Canvas for today, and you can go back, watch it, slow it down. But if A is increasing, A is some value. Let's just start with 3. And if I want to end up and still get A as my product, the answer, X has to be 1. Because 3 times what gives you 3? So X is 1. But if I increase it, if I increase A, let's make it 5. 5 times what gives me 5? It's still going to be 1. So it doesn't matter that A is increasing because your answer is that A. Does that help a little bit?
Yeah.
Okay. Okay. There you go. All right, the last one. says x divided by a is equal to 1. So as a is increasing, think about it. Look at that. Look at that, or look at it on your paper. As a is increasing, what is happening to x? Stays the same or what?
Or increase.
Well, it can't be both.
I think it's
Just increase.
I got an increase. 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 Well, okay. Are we just saying that?
No.
So as A increases, X is also going to increase. Why?
like if
You've
you
got to prove it.
2, that will give you 1.
That's right. If you want to end up with 1, as A gets bigger, X has to be the same value as A, right? Because the same number over itself is 1. So as A increases, let's make it 23. As A gets bigger, if we want to end up with 1, X also has to increase at the same amount. So as A increases, X will also increase. And more importantly, A is equal to X, or X is equal to A. They are the same amount. Any questions on those? Isn't that kind of interesting to think about them though? They're like, no, not really. It is for me. All right, now we are not done. Let's go to page 42. We're going to talk about headphones. Headphones. So we have a store selling 2 brands of headphones, high definition and basic. You've heard of those brands, right? High definition and basic. This store buys X number of headphones at Z dollars each. And they also purchase Y number of basic headphones at W dollars each. In problems A through C, write an equation whose solution is the given quantity. Now, I think that last part is kind of weird, but basically you are writing an equation based on the word problem that is presented to you. Okay, write an equation. We don't want to solve the equation. You will not be able to solve the equation, but you do need to write an equation. Okay? So, here's letter A. I'm going to give you time to work on it. The number of basic headphones the store can purchase. How many can they get if they spend a total of $10,000 on headphones and they buy 110 high definition sets for $70 each? So I want you to come up with an equation. All the important information is back here in this first paragraph. Okay? All right. Give it a try. 2 brands of headphones, high definition and basic. It buys X number of HD headphones at Z dollars each. Y number of basic headphones at W dollars each. So I'm going to give you just 3 minutes on this one. Talk to the people next to you. Hey, what's up? Ask yourself, self, what is X? What does X represent here? What is Z? Do I need that in this equation? What's Y? We need more thinkers in this world, and that is what we are trying to get you to do. Think critically. Think. We desperately need more thinkers. Wow. Did you hear that pop? Did you hear that pop? Oh, my knee. Snap, crackle, pop.